Okay, so number one, the first thing is, let's figure out what's not permitted on the bottom. Two and negative 2. Okay, if you, I guess I could factor it and we could see that a little bit better. Okay, are they asymptotes or would they be holes? Asymptotes. So I'm just going to put this here for myself, vertical asymptotes. There was no cancels. Okay, now I'm finding out that the degree situation is higher on the bottom, telling me y equals 0. I will draw, I have like a blank, like a grid on there.
Or is it to drive? Bro, it gets so messy though.
Yes, I've learned my lesson that reading people's graphs is sometimes tricky. Okay, what kind of values should I use in a table then? How do I pick those? I'm going to go a couple on this side, so I'm going to go with a -4 and a -3. I'm going to pick the ones in between, so I'm going to go -1, 0, 1. And I'm going to go on the right-hand side, 3 and 4. Okay, so plugging -4 in there, I get 4 divided by 16 minus 4. Which makes 4 over 12, which is, what is a decimal? 0.3. Okay, are you good for me to just write them all really fast now? We know how to do this. I'm just plugging in the values. This is good. Just to save time, are you ready? 0.8, -1.33, -1, and then do you understand that these ones are the same? Plugging in a -4 would result in the same as plugging in a +4 because you're just squaring it. Okay, graph. See if it fits with your asymptotes. Okay, so here's what my points look like. And when I connect on what's going on with the shape, that's what's happening. Okay, so I have my 3 asymptotes, so I have asymptotic behavior. You know what I'm also going to do on this one? I'm going to practice range and domain on this question because somewhere on your test you're going to get that. Okay, so let's practice a domain. Okay, so this graph starts out -infinity. What do we get up to where we have to jump over it?
-2.
-2, round bracket. Union, we start right away again, so -2, then we reach 2, we got to skip over it, and then right away we start again at 2, and then infinity. Okay, range, we're at a -infinity. We're down there. What do we get to when we have a stop?
-1.
-1. That is a square. Because it's a point, it's not an asymptote. And then, do you notice how this space, there's nothing going on? So we start again after 0. So now we're above 0 and heading up. And that's it. So basically, you can say I'm moving my pen up the page. So I'm here, -infinity, -1. Then I have to stop, lift my pen, and then I can start again 0 and go up, up, up. Okay, so it's me moving my pen and thinking, where do I have to lift my pen off? Okay, number 2, let's first talk. Not permitted values. What is x not allowed to be?
1.41421356.
Nope.
None of them.
None. None of them. All values are permitted. Did you do the square root of 2? The number you gave me was the... Okay, here's the thought process.
I rooted 2.
To get this bottom to be 0, x squared would have to be -2. And you're thinking, what number squares to ever be -2? Doesn't work. All numbers are good. So now, what's going on with the degrees? Higher bottom, y equals 0. Okay, I don't have any asymptotes, so where do I start plugging in numbers? How do I know what to pick? Well, you can pick anything. I'm going to do some basic values, which would be all the way from -2 to 2. Just, that's a basic number guess. Okay, should we do 1 and then I'll give you the rest. So let's do -2 plugged in. So 6 over -2 squared, which is 4, plus 2. So 6 over 6 is 1. And here's all the rest of your numbers when I plug them in. 1, 2, 3, 2, 1. Okay, I want you to be careful with the thought of what this shape is because you have to flatten. It's more of a shape of a bell. Okay, it's not pointy, it kind of curves and then it flattens. Okay, just a quick practice, domain and range. There was no non-permissible values, so your domain should be everything. The range would be, so the lowest I'm at is 0, but asymptote height, round bracket, up to exactly 3. Okay, then we have this one. So my first question is, what is not permitted? X equals 1 is not permitted. And does it cancel? No. So it's a vertical asymptote. Okay, degrees. What do we know about this degrees? They are the same. So we had a 4x and a 1x. Those are our liters. So when we divide the same, we get 4. Okay, I'm just going to give you the shape here just so we can move on. Just draw that just so we can move on here. Obviously on your test I want a couple exact points, but okay. Also on your test, I didn't have this as an example here, but sometimes you have a hole in the graph. Make sure if you have a hole in your graph, I can see the hole on your graph, right? Okay, this is irrational. We're going to get all the info we can about it. Okay, so let's factor the bottom. That's your first thing you should do. Okay, once I factored it, my non-permitted values were 2 and 1. But this one would cancel, so I'm going to write, there'd be a hole there, and I'm going to write VA there. When you're looking at the degrees, then what? There's more degree on the bottom, right? So y equals 0. This is just a 3x, and this is an x squared. Okay, so we have asymptotes of x equals 1 and y equals 0. Asymptotes are done. Okay, point of discontinuity, the hole is at 2, comma, but I'm asked for the coordinate. So I need 2, comma, how do I get that other part? Okay, so what I'm going to do is I'm going to cancel that And I'm going to input a 2 in there. Okay, so put it into the canceled equation, because obviously if you put it into the original, then there will end up being a divide by 0. Okay, so domain. These are the x values I don't want, 1 and 2. So you can write with a bunch of little sections if you want, or you can write me it either way. Some of you might prefer one way over the other. Okay, so you have to skip over 1 somewhere and you have to skip over 2. You have to skip over your hole as well as your asymptote, right? So if you're looking particularly at a graph that has a hole in it, make sure you're also skipping over that. So range, we have to skip over the height of our asymptote at 0. And we also have to skip over the height of the hole. Skipping over the asymptotes and the holes. So y can be anything except 0 or 3. Okay, let's move on to now some radical stuff. We have a domain that is bigger than or equal to, so we are going that way. We're bigger than, we're heading to the right. This symbol says less than. Okay, so there's a very simple idea of what's it's looking like. Okay, starting point, and then I'm going right down. Okay, I'm going to put in here, I'm leaving a little bit of space just in case I have to put some kind of b in there. I'm not sure yet, so I'm going to leave myself a little bit of room here. X plus 2 is the cause of it moving left 2. That's going to cause it to move up 3. And there is a reflection because I should look like this, but I look like that. Is that going to go in the A position or the B position? Which one is that? The A. Okay. If it happened to be the B, you need to throw brackets around there like it's factored out, right? Factored out B's. -1 bracket. Okay, write a rational. So give me a rational, which is a fraction. To have a vertical asymptote at 3 means there's a factor x minus 3 on the bottom. To have a hole at -1 you need an x plus 1, but you also better put it on the top to make a cancel of it. Okay, and that's it. You're done that question. I probably wouldn't do something that simple. I might add something about a horizontal asymptote. So what if I added a horizontal asymptote at 5? What else would you add into this? You would need to put a 5x. Because a 5x times this would create a x squared unit, and the bottom is x squared. So you would have to put something multiplying another x to cause an x squared. And you could put a 10 here and then a 2 here or whatever, right? So just be careful for that info. Okay, graph. Okay, what is the starting point? Moving left, right, up, down. Where have we moved? There's no C, and a -4 is the D. And then I have an over-up pattern, and I always start 1, 1, 4, 2, 9, 3. Okay, so this is the idea. Over is x. What do we have to do with x stuff? We have to divide by b. The up is an y. What do we have to do with y's? We have to times by a. So I'm going to be dividing this one by a -1, and I'm going to be timesing this column by a 2. Okay, this reminds me, I'm going to have to flip back to my first page because I would deduct myself points. Something that I missed here and on my first page. I've lost points on my test. Why? I forgot to put a label. There, I'm done. If I do this, I've labeled each tick with a 1. It's done. But if you don't do something like that, you lose points. So this person, like me, lost points. All you have to do is put a 1. Okay, so I need some kind of value somewhere on each axis. Okay, determine the equation. So -4, comma, -3. Okay, I'm going to leave myself room for A and room for B in case I need it. Okay, x plus 4. And then afterwards, I need a minus 3. Okay, we need to find some points here. Okay, so what I did was I drew my normal 1, 1, 4, 2, 3, 9, and I'm going to draw the path that I took now. Okay, so I found a point here. So this is over, oh, this is awkward. Look at your scale. I don't like that. That is over 1. Down 1. That was awkward. I was going to write 2, but I didn't notice that my tick marks are not that. So then this point would be over 4 and down 2. So what is the thing that changed? This got times by -1, which is a A. And I guess there's no B. Okay, but be ready to insert your B with a factored out bracket, right? Okay, given this graph, you need to graph the square root of it. Okay, so I'm looking for some ideas. The first idea is understanding that part of the graph will not be able to square root that part. The second part I'm looking for is which square root heights are invariant. What number do you square root that doesn't change? 0 and a height of 1. Heights of 1 stay at 1. Heights of 0 stay at 0. Okay, then I'm looking for heights that are decimal heights between 0 and 1. What happens to you when you square root decimal numbers? They go bigger. So I need to see bigger there. And then this section would go smaller. So specifically I'm going to grab 3, 4, and I'm going to move it to 3, 2. This graph ends at 4, 6. I don't know what the square root of 6 is. So the square root of 6, if you want to graph it, is 2.45. Okay, and obviously it makes the shape of a radical, right? Okay, solving for radicals. Okay, as well, you might see questions about that concept related to specifically understanding invariant points, understanding domain and range on that as well. Okay, solve. So you need your algebra here. We're going to -1. Then I'm going to divide by 2. Now I'm going to square both sides. And then subtract 3. Okay, we're going to graph this and see if it matches on your test. If they don't match, something went wrong, okay? So when I graph, I have to get everything to one side. Okay, so when you graph, you need a y equals equation. So that means every single thing has to be on the same side. So I'm moving the 3 over. Okay, so this equation would start at -3, -2. And then I have an A, so I'm going to move over 1, up 2. Boom, there it is. I already had it. Okay, again, you're going to get that on a test. If they are not matching, then you got to go back, see what you did. Okay? On your radicals, I think I'm going to ask for 3 points. So. Okay, so what are the rules for understanding vertical asymptotes versus a hole? So we can do something like this. So understanding when there's a factor or an x on the bottom that you're looking at, it creates a vertical asymptote. I think you guys need more practice at this. What's the actual coordinate of that hole? 3, comma, what? Somebody said it? 1. Because when I cancel that, it just makes 1. Okay, so that's the vertical asymptote rules. So the horizontal when the degree is higher on the top, what's going to happen? there's going to be no restrictions. Your number just gets bigger, bigger, bigger. That's it. It just goes up. And the other rule is if the degree is higher on the bottom, your number gets smaller, 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 which means you go to 0. And the other rule is if you have the same degree, what do? Y equals some kind of number. And that is whatever you get when you divide the coefficients, the leading coefficients. Okay, last question. Graph. And this one I'm trying to trick you on. What is the thing I'm trying to trick you with? How many people are going to get fooled by me? I'm being sneaky here. What's the actual equation that I should think about? What's wrong with what I did? I didn't factor it out. Did you catch it? So 1/2 should be outside of brackets. What else do I need in there now? I'll give you multiple choice. Should I put a 2 there or an 8 there? I needed 8. 1/2 times x makes the 1/2 x. 1/2 times 8 makes the 4. Okay. My start is now -8, +2. You guys know that I'm totally going to put one of these on the test where I try to trick you without the factored out, right? Okay, there's my start. Let's make a chart. Over, up, 1, 1, 4, 2, 9, 3. Okay, the over is going to get divided by 1/2, and the up is going to be getting times by -1. What's the same math stuff as dividing by a 1/2? Dividing by a 1/2 could also be the same as doing what? Timesing by 2. Right? 1 divided by a 1/2 ends up resulting in a 2. Okay, here's another thing we can think about. If B is a 1/2, don't we remember the words of that? It's a horizontal stretch. Changing 1 to 2 is stretching it, right? Okay, there you go. So go right 2, down 1. Ooh, does yours hit the origin? I think that's it. 3 points is what I kind of require from you. Okay, and my scale's already on there, so now I don't have to worry about that. Have we done one of these where we have to state the domain and range? I'm not sure, because that's on your test. So the domain goes from -8 to infinity. And the range goes from -infinity and then up to 2. Okay, I could also ask questions about intercepts as well as domain range, so be ready for like any kind of follow-up questions like that.